Okay, so as I promised that today I'm gonna do statistics, since on our first session things were just really on everywhere. People were not sure what is happening and all that. So basically I'll be conducting my lessons in this way. So it means that I'll have a whiteboard and then I will be able to write things on the screen, and then you will be able to see what is happening. Okay, so with stats, I hope you have done stats at school maybe, and then you might be familiar with some of the concept here. So I'm just gonna brush it up a bit, and as we continue with this lesson. So we're gonna be looking at statistics, and with statistics we start with ungrouped data. Instead there's grouped data and ungrouped data, but in order for one to understand the concept, we start to apply it on ungrouped data. So the first thing that we look at is the measure of central tendencies. So these are concepts like mean, median, and mode. So this type of concept, they look at a data around its central measurements. So this means that if you have a data which is not grouped, then you can be able to calculate a mean using this formula. So a mean is written in the form of x bar is equals to the sum of x scores. So it means that you add the total of the data and you divide by the n. So n represent the number of scores. Okay, and then the median, we all know that median is the middle number of the data. So sometimes you can actually represent a data, or you can actually find the median of the data using a formula, which is m is equals to 1 over 2 n plus 1. So this formula right here, it doesn't calculate the median, it just tells you the position on the data. So in order for us to apply this concept, we will look into this data here as an example. But for now, so it means that if you want to determine the median of the data, and maybe it's a lot that you can't actually start counting, you can simply use this formula. So half multiplied by n plus 1. So n also represents the number of scores. And then our second term is the mode. The mode, we all know that the mode is the number with the highest frequency. So the number that you see a lot in the data, that number is called the mode. Okay, so now I have a little example here in which we are going to determine the following three measure of central tendencies: mean, median, and mode. So the data, let me calculate how many data I have. It's 1 2 3 4 5 1 2 3 4 5 6 7 8 9 10 11 12 13. So sometimes you can get a data which is not arranged. So this means that when you have a data, first check if the data is arranged or it's not. So if the data is not arranged, then you must rearrange it from the smallest to the highest. So in this example, the data is already arranged. The smallest number is 1, the biggest number is 25, and the rest is following the ascending order. So this means that if I want to calculate the mean using this data, you can actually add all these scores all together. So I'm gonna actually leave that to you to calculate the mean, median, and mode, and you're gonna give me the answer. So I'm gonna give you like let's say 5 minutes to do this small activity. Okay, Sandiso, are you still here? Okay, so did you hear everything that I was saying? Okay, so like I said, this is a small brush up activity. I'm sure you already know how to calculate the mean, you already know how to determine the median, and then you already know how to find the mode. So this is what you're gonna do for me right now. So I'm gonna give you 5 minutes to calculate this 3 data for me. Okay, yeah, so after you're done, you will give me the answer and I'll write them on the screen. Is it 12 or 13? Let's count. Let's count. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, it's 13. So it means I missed one of the numbers. 1, 2, 3. Okay, but it's fine. Okay, so you entered 13 data on the calculator, right? Yeah, so this means that now you will press AC. Let me just do this first. I'm gonna enter the data as well, so I'm restarting again. 2, 2, 2, 3, 5, 6, 6, 7, 7, 8, 25. So you press AC and then you press shift. Now you go to shift and then you press number 1. If you see number 1, it has state written on yellow. You see that? Yeah, so you press shift and then you press 1 and then you will have 5 options. Do you see them? Okay, so you want to find mean, so it means that you're gonna press option number 4. Option number 4 is written var, so that's the option you're selecting. So you will see 4 options again. You will see n, so that n represents the number of data. So if you press 1 and equals to, you will see 13. Can you see that? Yeah, so this means that if you want to confirm that you entered the correct number of data, then you check using that option. Then you press AC again, then you go and shift and then you press 1, then you press 4 again, and then you see option 2, it has X bar. Then X bar is our mean. Then you press that option number 2 and then you press equals to, and then you will see your answer there, 5.76. right? So that is the most information that you can use when you use a calculator. So for your grade 10, mostly what you will use the state table for, it will be for finding mean and calculating or finding the number of the data, and then other stuff. Number 3, I think, is the I'm not sure if it's the variance, and then number 4 is the standard deviation, but I'm not sure. But the most things that you will do the most is option number 1 and number 2, but usually option number 2 because you just want to find the mean. Okay, yeah, so I hope you won't forget that again. Okay, now we are done with mean, median, and mode in and ungrouped data. But remember, whenever you find data, you must first check if it's grouped or no, if it's actually like ordered or not. So if the data is not in an ascending order, you must start to rearrange it from the smallest to the largest. But this one, since it's already in the ordered form, or it's already arranged, then you don't have to worry about that. So we are moving to measures of positions. So you know things like quartiles. With quartiles, you know, we have, how many quartiles do we have? If I can just, we have 3, which is quartile 1, quartile 2, and quartile 3. Okay, so this is our first quartile. This one is our second quartile, which can also represent what? The median. So second quartile is the median of the data. And then we also have the third quartile, so please, my handwriting can be ugly when I'm using this platform, so I hope that you will see properly. Okay, so here as well, it's all about finding you will start, so if you have a data, so you're given a data which is, let me just give an example, and then I will show you how to find this quartiles. But for the median, we already know because it's a median. So I'm just gonna go to a new page. Let me just remove this. Then I say quartiles. Then I have example. So in this example, you will have let's say you have 2, 3, 4, 5, not 55, oh my god, but 5, and then another 5 again, then there's 6, there's 7, and then there's 7, then there's 8, there's 9, that is 10 and 10. And then we need to find first quartile. Let me just write it. Determine the quartiles, let me just say quartiles of the data. So when I say quartiles, it means I'm actually including all 3 quartiles. So you will have Q1, then Q2, and Q3. Then maybe to make things easier, let's see how many data we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 data again. Okay, so I'm gonna start by finding the median. So median will be 1/2 n plus 1, which is equals to 1/2 is 13 plus 1, which is equals to 1/2 plus multiplied by 14, which is 7. So let me write in red and say position 7 of the data. So 7 is not our median, but it is where I'm going to find the median. So it means that I'm gonna count 1 2 3 4 5 6 7. So this position is position 7. So they mean that therefore my my median will be this number here, which is 6. So I'm just gonna say median is equals to 6 in blue. And then so you already determined the median here. Then you're gonna have to go to Q1. So you know Q1 is the first half of our data. So the data now is divided in 2, since you already determined the median. So the data now is divided in 2. So from here going to the left is the first half of the data. So for the first quartile, it means we're going to find the median of this set. So it means that I'm just gonna say how many numbers do I have? 1 2 3 4 5 6. I have 6 sets of data on the first half of this. So the middle set, I'll just go like this, and then this way and that way, and then here and here. So it means I am actually stuck with these 2 numbers. Since this first half is in the even number, it means that my median of the first, my first quartile will be somewhere here. So what will I do if I have 2 numbers which are in the center? I will have to add them and divide by 2. So it means for first quartile I will have 4 plus 5 divide by 2. 4 plus 5 divided by 2 will be 4.5. That is the first quartile. And then the third quartile is the second half of the data. So the data over here, that is where you're going to find the median of this data. So you can actually calculate that for me. So is this number cancel with that, 7 and 10, then you are stuck with these 2 numbers over here. So this means you are going to add these 2 numbers and then you divide by 2. Yes. So what is the answer? 8,5. So let me write that with blue so that it can have some logic. So 8.5, and then this one is 4.5. So those are the positions, or these are the measures of the positions of the data. So first quartile, second quartile, and third quartile. So another measure of positions that is used in stats is percentiles. Percentiles. I don't know if you've heard this before, have you? Okay, so percentiles is just the form of percentages, indicating data or determining data using percentages. So basically I will show you in exams how they ask questions based on percentiles, but then in this example it's not going to, it's just you to understand how to use percentiles to find information. So it means that I'll give you a data here which is 53, 94, 85, 71, 97, 32, 92, 88, 81, 75, and then 67 and 74. So this data actually represents the marks obtained in the class. So maybe there was a test written in the class, and these are the marks which were obtained in the class. Let me put it like, these are the marks obtained in the class. So different learners obtained different marks in this way, and these marks are in the form of percentage. So this means that if I want you to calculate the one, they say calculate the 60th percentiles of the data. So what you will do here is, first thing first, this is the rule of stats, you must always remember it. Arrange the data in ascending order. So you're gonna arrange this data from the smallest to the highest. So my smallest number is 32, then followed by 53, then followed by 67, and then followed by 71, then followed by please help me again, 75, then no, not 75, 74, 75, 81, 85, 88, 92, 94, then 97. Let me check, how many data do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, good. So now this data is arranged from the smallest to the highest, and then I want to calculate the 60th percentile of this data. So what happens is that, first step, arrange the data in ascending order. Second step, then you will use this formula. There's a formula that you have to use, which is, you want to find the location where 60th percentile data is going to be at. So to calculate the position, it means you will have small I. Small I means the location or position. Location, let me say location, then you say P over 100, and then multiply by N. So N indicate the total number of the data, P represent this percentile over here, which is 60th. So it means that if I continue, I will have 60th divided by 100 multiplied by 12. So that will give me, oh god, what did I do? 60 divided by 100 . Okay, this will give me 7.2. Okay, so you come to your data here. 7.2 is the position. Is the position of this data, of where you're going to find 60th percent. So 1, 2, 3, 4, 5, 6, 7. But this is 7.2. So 7.2, it means you have to round this number, but if you round it, it will actually go back to 7, because 2 is less than 5, so it won't actually change the number over there. So this means that you will look at the 7th position in this data. 1, 2, 3, 4, 5, 6, 7. So here, so this position, that is where you're going to find your 60th percentile. So this means is 81. Okay, 81%, or no, you don't have to write percent, but this is the mark which was obtained in the 60th percentile. Okay, yeah, that's how you calculate percentiles. But usually instead, the most percentiles that are important are the following. We have, since you already learned about quartiles, so this means that we can actually now talk about percentiles in the form of quartiles. So you know Q1 of the data, Q2 of the data, and then Q3 of the data. So Q1 of the data is the 25% of the data, and then Q2, remember Q2 is our median, which is 50% of the data, and then Q3 is 75% of the data. So you see, you have, let me draw something like a line. Let me draw something like a line. Oh, good. To show you exactly what I'm trying to say. So this is a line over here. So this line I divided by 2. So this is my Q2, which means is the 50%, right? You agree, right? Yes. So 25% is the quarter, is the first quarter of the half. So you cut the data into half, you get 50%. That is the percentile. And then you chop the quarter, the half in half to get 2 quarters. So in this point, you will have 25% of the data. And then on the other side of the half, you also chop that data into half as well. Then this will give you what? The 75% of the data, which is the third quartile. This is the lower quartile, this is the higher quartile, this is the first quartile, this is the third quartile. This is our median. Okay, so yes, so this is how we apply percentiles the most in the stats. So I don't know if you want maybe a little activity to actually kind of practice this type of information. I can give you one. Okay, so maybe let me just say calculate. Where can I squeeze this question? Let me just rewrite this data again. Second example, I have 32. Please call out the data again. Did you capture it? Okay, please call it out for me. It's 32. Okay, 6, 7. Yeah. Okay. Okay, I'm just gonna give you 2 questions. Number 1, calculate the 70th percentile of this data. Then numbers B, calculate the 25th percentile of this data, of the data, not of this that. Wow. Yes, so you're just gonna do this 2 questions, and then we move to other concept. Maybe I'll give you how many minutes? 5, I think. Yeah, 5 minutes. Our formula is location is equals to percentile divided by 100 multiplied by the number of data. That is the formula. And this just gives you the location, so it means after you calculate this, you find the position, then from there you go and look at the position that you're going to find, and then you told me you find the actual answer. So the first one, what is the position? I is equals to 70 divided by 100 multiplied by 12, right? Which is equals to Sandiso. Oh, you're still calculating. Sandiso. 8.5. No, not 8.5, but 8.4. Wait, are you still with me? So this number, if you round it, it will give you what? Okay, so if we go to position 8, it means it's 1, 2, 3, 4, 5, 6, 7, 8. So our answer is what? 80, 85. For the second one, our position is 25%, which is 25 over 100 multiplied by 12, which is equals to is 3. Okay, so here this is what happens. Remember, we were getting 8.284, 8 point something, so it means you round off the data. But now if you find that your data is like a real number, like a number is an integer, 1, 2, 3, 4 and all and so on, it doesn't literally mean that you must go and say 1, 2, 3. No, not really. What happens is that you found that your position is I, which is 3, right? So you're gonna go and count up to 3. So this is 3, and then you have this number again. So you must take this number, which is the third number, and then take this number as well. So if the I value is an integer, like, or a counting number, let me put it, because if I use integer, it's wrong, because integer actually involves negative numbers and 0, and this is not actually, those are not the counting numbers. So let me just say n as natural numbers. Natural numbers start at 1, 2, 3, 4, 5, 2. These are the counting numbers if we talk about the set of numbers, different numbers. So if the I is in the set of natural numbers, it means that you must actually have I and then add it with I plus 1. Then you divide that by 2. So what does that mean? In our case, my I is equals to 3, and then my fourth position is, okay, so it's actually like I, and then I plus 1 is 3 plus 1, which is equals to 4. Okay, so this means that the number that I'll find here in this position, I'll add it with this one and I divide by 2. So I'm gonna have 67 plus 71, then divide that by 2, which will give me 67 plus 71 divided by 2, which is 69%. So no, actually let me not write percent, because that's not exactly what I'm looking for. So it means that the 25th percentile of this data is 69. It's 69. It's not 67. It's not 67 but 69. And how do we get that? It's because you found that your number or the location of the percentile was in the form of a natural number. So it's not in the form of a decimal. But if it's in the form of decimal, you round and then you go and look at that position. But if it's in the form of a natural number, then you will go to that number that you will find, and then you add that number with the second number which follows that one, then you divide by 2, then you get your actual 25th percentile of the data, right? Okay, I hope you understood. Okay, so let's move on. Stats, we're about to finish maybe. So now we're gonna look at things such as measures of dispersion. So what are we talking about here? We talk about the concepts such as range, and then we talk about interquartile range, and then we talk about semi-interquartile range. So range is the bigger number minus smaller number. So max number subtract minimum number. And then interquartile range is the range between the quartiles. So we have lower quartile and higher quartile. So this means that our interquartile range will be, our higher quartile is Q3 minus our lower quartile, which is Q1. And then the semi-interquartile range is the half of the interquartile range. So this means that the interquartile range divide by 2. So this is actually not Q2 but Q3. Okay. Yeah, so interquartile range can also be referred as IQR. So this means that is interquartile range. So this means that I don't know, you already know this concept, or you also need to have an example, or actually I will actually summarize this or by a set of questions. So I'm going to give you a set of questions which will involve all these concepts that you have applied. So because range, you just have to know the maximum number and the minimum number, and then you subtract the two. Interquartile range, you find the higher quartile range and the smaller quartile range. Semi-interquartile range is the half of the IQR. So I can just simply say 1 over 2 of the IQR. That is the semi-interquartile range. So maybe I can just continue by concluding this whole concept by doing the box and the whisker diagram. I hope you've done that in school, have you? Okay, so this is also like a brush up. So when we talk about the box and the whisker diagram, it means that first we talk about 5 number summary. Yes, 5 number summary. So this means that number 1 we talk about the minimum, then we talk about the maximum, then we talk about the not maximum, no, wow. Maximum will come up at the maximum. So we talk about Q1, which is the lower quartile or first quartile. And then we talk about Q2, which is the median. And then we talk about the Q3, which is the higher or the third quartile. And then actually this is number 4. Number 4, then number 5, we talk about the maximum. Okay, so I'm just gonna give you a small activity that you will do, because like now I want to actually focus on the serious question now. You will do that on your own time. I'm just going to give you a data. Activity. Wow. Activity. Given the following data. Four, 3, not 33, but 3, 6, 7, 8, 2, then 2 again, and then 9, 10, then 1, then there's 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, not 30, no, let me just say. Then there's 4 again, and then there's 1, and then the stage. So determine the following. Number 1, mean, median, and the mode. There is something that I didn't actually mention when it comes to median. So if you have a data and it's in the even form, like let's say you have something like 1, 2, 3, 4, and then I say find the median of this data. Yes, so maybe let me just use my formula, 1 over 2 over n plus 1. So my data is actually like 1 over 2 divided by 4 plus 1, which is gonna give me 5 divided by 2, which is 5. Wait, is that 5 divided by 2, which is 2.5. So what does that mean? If you have because this is, you calculate the position and then you come here and then you say 1 and then you have 2, so it means that your median is somewhere here. So it means that what you're gonna do is that you add this number and this number, then you divide by 2 to find the median. You know this, right? Okay, so if the set of data is in the even form and you are to find the median, and the median it actually cuts the number or the data into half, so it means that you will add these two numbers, and then you divide them by 2 to find the median. But I'm not sure about these activities because I'm not sure how many data you have. But number 2, we looked into it. Or first, second. Find, oh, I can't actually repeat that question. Determine the following: mean, median, and the mode. And then second one, the quartiles. It means that it's all the quartiles from Q1 up to Q3. Quartiles of the data. Then number 3, we find the range. And then number 4, find the IQR. And then number 5, find the semi IQR. Then number 6, write down the 5 number summary. And then number 7, draw the box and whisker diagram. All right, this is the activity. You will do that on your own time. So this is like determine the following. So you do that on when you are studying, then, or before you sleep or anything. Then mean, median, mode, quartiles of the data, range, IQR. This means interquartile range. Then semi-interquartile range, write down the 5 number summary, draw the box and the whisker diagram. So we are done analyzing data in an ungrouped data. Okay, so this means that I'm gonna move to the next section, which is a grouped data. So in grouped data, here now we represent data in the form of a table, in the form of graphs, in the form of different graphs like bar graph, line graph, or histogram. But we also apply the same concept as to find the mean of the data, the median of the data, the mode of the data, and we can find the range, the maximum or minimum. We can all do that. So here I'm not going to talk much, but I'll just try to touch on I'll just use this or teach this using an actual example from the question paper. So let me find a certain example that will be suitable to my god.